السلام عليكم في مادة تطوير وتصميم قواعد البيانات. Mm, Welcome to Unit 1, Data Modeling. Today, we are going to explore how data is organized and stored in databases. Even if you have never worked with databases before, by the end of the session, you will understand the basics of data modeling and how it's used in real-world systems like hospitals, schools, and online stores. Let's start with the basics. A database is like a digital filing cabinet. It's a place where we store and organize data so that it can be easily accessed and managed. For example, think of a phone book. You know the phone book? It's a database of names, phones, numbers, and addresses. Or think of a library catalog. It's a database of books, authors, and journalists. Databases are everywhere. Hospitals use them to store patient records. Schools use them to track student grades. And online stores use them to manage products and orders. But how do we design databases? That's where data modeling comes in. Data modeling is the process of creating a blueprint for how data will be stored and organized in a database. Think of it like designing a house before building it. You need to know where the rooms will be, how they will connect, and what furniture will go where. In data modeling, we decide what entities are things. So each entity is something like person, store, or something like that. In data modeling, we decide what entities or things we need to store, what attributes, that means the details of the entity and they these entity have and how they are related to each other. For example, in a doctor's office, we might need to store information about patients, doctors, and appointments. These are three different entities. Okay, when we speak about patients, we can speak about different attributes like name, address, mobile number, and so on. The doctors, like a person, like a patient, they have numbers, names, and so things. These are the properties or the attributes. Let's break down some key terminologies. A data model is the blueprint of how data will be stored and accessed. A logical data model shows how data is organized without worrying about how it will be stored. It's like a rough sketch of the house. A physical data model shows how data will actually be stored in the database. This is like the detailed architecture plan. Normalization, that is another terminology. Normalization is a process we use to make sure the data model is efficient and free of errors. We will talk more about this later in this chapter. An entity relationship diagram, or in short ERD, is a visual tool we use to represent the data in a system. It shows the entities, as we agreed, the things, and their attributes, as we agreed, their properties, and the relationships between them, how these entities are related each to other. For example, in a doctor's office, we might have entities like patient, doctor, and appointment. The ERD would show how these entities are connected, like how a patient schedules an appointment with a doctor. ERDs also show business rules, which are constraints which are constraints or guidelines for how the system should work. For example, a business rule might say that a patient can't schedule an appointment without a doctor. So, if we don't have a doctor connected to an appointment, we can't create an appointment instance in our database. Let's look at an example ERD of a doctor's office. Entities are patients, doctor, appointment, and bill. Each rectangle here, each box here is an entity. Doctor, appointment, patient, insurance company, payment, and a bill. The relationship is like a patient schedule an appointment. Let's look at a patient can schedule an appointment. Patient schedule an appointment. This line and this sentence describe a relation between these two entities. Now looking to these small symbols, okay? These small symbols can say some business rules like cardinality and modality. Okay, when we speak about cardinality here, we can say one doctor, only one doctor can have many appointments. Look at these three lines at the end. This means many instances for, and we have the first like a column, like a line. Okay, this one says we have one instance of this relation associated or connected to multiple instances of this entity. Okay, so in this relation we say it's one too many, and that is the cardinality. It's one too many. When we speak about modality, this means a patient as example. Let's look at a patient. Okay, a patient as example must have an appointment. Must have an appointment, and this is the second line here and the second line here. This says a relationship can't exist without the both sides. So it's required on the side of patient, and for sure it's required on the side of appointment. Look here, we have another symbol, by the way, which is the ellipse, okay, or the small circle. Look to this small circle. It says a patient can exist, but it's not sure or not covered by insurance company. This means not every patient is covered by an insurance company. So we have some insurance company that has no patients. Okay, okay, I think I said that incorrectly. The relation here is one too many. Okay, one too many. All right, and the side of one cannot exist. Okay, again, not every patient belongs to an insurance company. I said it correctly. Okay, now looking to this diagram, we can understand the data in our system and how they are organized, and furthermore how they are connected each other, and furthermore it can state some business rules. Inside the entity relationship diagrams, let's look at the key elements of an ERD again. We can speak about entities. These are the things we are storing data about, like patient, doctor, or appointment. Let's speak about the second element of the ERD. It's the attributes. These are the details about each entity. For example, a patient might have attributes like patient ID, name, and phone number as example. Again, inside the ERD, we can see the relationships. What is the relationships? These show how entities are connected. For example, a patient schedule an appointment. The ERD tell us the cardinality and modality. What is the cardinality? This tells us how many instances of one entity relate to another. For example, one doctor can have many appointments, but each appointment is for only and only one doctor. When speak about modality, this tells us whether a relationship is required or optional. For example, a patient must have an appointment, but an appointment doesn't have to have a payment right away. Let's look back to see this modality between patient and appointment and payment. Okay, where is the appointment? Wow, it's a long one. Okay, creating an ERD is a step-by-step process. Okay, first we identify entities, find the main categories of information. For example, in a doctor's office, the entities might be patient, doctor, and appointment. But if we speak about the college, we can speak about courses, students, semesters, instructors, and colleges. Okay. Then, after you identify entities, you go to step 2. Step 2, add the attributes. Adding attributes is add details to each entity. For example, for a patient might have attributes like name, phone number, and address. After we defining the attributes, we go to step 3, identify relationships. Show how entities are connected. For example, a patient schedules an appointment, and that is a relation is identified by this business rule. And finally, we determine cardinality and modality for each relation to know which part is required and how many instances can exist for that relation. Now, let's talk about some advanced concepts in databases. We need to categorize the entities into 3 categories. The first type of entity that we may face when designing our databases is called independent entity. This is an entity that can exist on its own, like a doctor or a patient. It doesn't require to have something else to exist in our system. So the patient can be created immediately, and we don't need to create something else before creating it. So we call this entity an independent entity. The second type of entities in our database, we call it dependent entity. Dependent entity, this is an entity that needs another entity to exist, like an appointment which needs a doctor and a patient. We can't create an appointment without having a doctor and a patient. Okay? And because of that, we call this type of entities dependent entity. They are not independent. And finally, we have the third type of entities, and we call it intersection entity. This is used to capture information about the relationship between 2 entities. So if we have 2 entities, that they have a relationship between each and other, but this relationship has its own attributes, so we call this type of entity an intersection entity. For example, if a student can enroll in many courses and a course can have many students, we might need an intersection entity called enrollment to store information about which students are in which courses. Usually, intersection entity comes from a relation of many to many cardinality. Okay, so if you have multiple like students and course, as you know, each student can learn multiple courses in the same semester, and each course is learned by multiple students in the same semester. So the relation between the course and the student is many to many. For that reason, maybe we need an intersection entity called something like enrollment. Okay, we will see that in action later. Now, what is normalization? We say normalization is a process we use to make sure our data model is efficient and free of errors. It involves organizing the data into tables and eliminating redundancy. There are 3 main normal forms. Now, this process is something about thinking how we can fix our data model to align with best practices and good design principles. Okay, and this process to be sure that we are to make sure that we are organizing our data in the light of the best practices in the field or in this industry, as well as the design principles. Okay, and to do that, we usually go from a normal form to a normal form. What is the normal form? It's a state of data arrangement that meets some conditions. Okay, and it's an initial step to go further in our normalization process to go to the next step. Look at your data model as something that can grow or maybe enhanced. So we have different grade of these enhancement. So each enhancement should meet some conditions, and we call these conditions normal form or the normal form rules. Okay, we have three normal forms in this course, and we will explain these three normal forms only, but in the real life, after you graduate, you may face more than these the three. Maybe you can find up to six normal forms, or maybe seven sometimes. Okay, so the first normal form has very basic and simple rule. No repeating groups or attributes. So we don't repeat columns and we don't repeat attributes inside a column. Okay? The second normal form, it speaks about all attributes depend on the entire primary key. On the second normal form, we are looking to a table and its a primary key, and try to associate each attribute in that table to its primary key. And if each attribute depend on the primary key, so we are in the second form. But if some of these attributes doesn't belong or it doesn't depend on the primary key or depend on part of the primary key, that violate the second normal form rule. By the way, the primary key is one attribute that identify the complete instance of that entity. As example, if we are speaking about a student and we have the identity number of a student as example, and we can know the student based on the identity number, we can call the identity number a primary key because it identifies the student. In the, let's say, in the college, we have a student number. Student number you get once you register in the college. So a student number can identify the student as well. So that is can be a good primary key. For instructor, as example, we may have the employment number. As employee in another one, we have the unique number. And by the way, primary key should not be repeated for different instances or for different objects of that entity. So two students can't have the same identity number, two students can't have the same student number. Okay, that is the primary key. Now let's go back to the third normal form, the third one. The third normal form, no attributes depend on non-key attributes. This means if we have a table and we have a lot of attributes, we can't if we find an attribute or a property that depend on another attribute and this last one is not a primary key, so we are violating the third normal form. Lastly, in this point, we can't speak about the second normal form, rule unless our model completely satisfy the first normal form rule, and we can't speak about the third normal form rule without making sure our model satisfy the second and the first rules. Okay, we will take that in action